Hello everyone. Today I will give you a brief introduction of the Year 2 project. This project covers a temperature-controlled circuit. It can be used in the conveyor belt. As you can see, the soldering rod can be divided into two parts, driven by two Arduino UNO board. For this part, this is the temperature-controlled temperature, as you can see, circuit. We use the PID feedback controller to control the overall temperatures around this circuit. As you can see, here is our one potentiometer. It can transduce the voltage signals into a temperature signal into the Arduino board. This will be the set point of your PID controller. Besides, here is a electric fan. You can regard this electric fan as the plant of your system. The control signal will be generated from the Arduino UNO board to trigger this or to actuate this electric fan. Here is a LM35 thermistor. It can detect the current state of the temperature. Also, it can be regarded as a process variable in the PID control system. Here is the NPN transistor to buffer the electric fan circuit and the Arduino circuit. Alright, here is another part. This part is a little bit complicated. It covers lots of functions. Basically, this is a temperature-controlled speed circuit. You can imagine one condition. If the temperature is overheated, for example, in a cake baking belt, when the temperature goes high, you might speed the belt up to maintain the overall period of the heating in one cake, for example. Okay, I'll explain the components part by part. Here is our Arduino UNO chip as this one. We use two chips just to avoid the complicating of the two circuits. You can combine them together. Okay, here is also a LM35 thermistor that can detect the change of the temperature. Once the temperature is changing, it will output to the Arduino board a voltage change to this pin. Also, the Arduino UNO board will using the map function to deliver a linear relationship of changing in the motor speed. Here is our motor, as you can see here, one motor. It represents the speed of the conveyor belt. Okay. Here is our LCD display. As you can see, it displays the temperature and the current temperature, also the process variable in the circuit, and the fan speed or the motor speed. Here the surrounding temperature is around 22 degrees, and the speed of the motor is just 0. We programmed this circuit to, when the temperature is higher than 40 degrees, it will be triggered at 100% and will speed up if the temperature just goes up. Here is also a potentiometer. This potentiometer is just a funny thing. It can control the lightness of the LCD display. As you can see, the light goes down and the light goes high. Okay. Here is another interesting component, ultrasonic emitter and detector pairs. Okay, you see, it's triggered up. Oh, I disconnect this thing. Let me solve this problem. Okay. Right. Let me just adjust the display. Everything will be fine. Here, you can regard this as a obstacle avoiding component. As I'll show you, when my hands becomes near to the ultrasonic detector, as you can see, when the distance becomes lower, the frequency will just become narrower or larger. When the distance is narrower than 5 centimeters, it will output a constant buzzing. Okay, just buy this small buzzer and it will stop the whole circuit. Here is also a NPN transistor to buffer these two circuits. You can imagine our PWM output of the Arduino chip as the open or cut off switch of this transistor. If the voltage, the temperature goes high, the duty time of the PWM voltage pulse will also be triggered higher, and the working time of this transistor will also be extended so that your average voltage on this motor will also become longer. Okay, here is all the component and basic connections of our project. Now I'll show you how these things work. I'll check this circuit part by part here. First, for the temperature controlled circuit, here is our code, just in case, as you can see. Okay, we will start the serial monitor. You can see here the temperature is just 22, just as the LCD display, and here is your set point. You can imagine this value is a set temperature that you can that you want to control this this overall conveyor belt to a comfortable working mode. And this is the transduced or converted version of this set temperature. It is, you can imagine this is a proportional speed of the motor in the set point version. Here is the input temperature, just the current state or process variable of your PID control, and this is also a converted speed of your PID control. As you can see here, the set point is just higher than the input, so you can see that the working temperature is lower than your set temperature. So the output, the fine speed is 0. So it won't be triggered out. Okay, if I just change the set point by adjusting the voltage, the potential meter here, as you can see, when I do these things, right, the set point is lower than the right. Let me just check this circuit. Okay. Here now, your set temperature is just lower than your input temperature, or you can see the set point is just lower than your input. So the fan will start working. You can see here from a very low value and become higher up to the full speed to cool down this circuit. So you can see the fan is just working. Okay, I'll test this circuit for another application. Here we change this potential meter to make this value up, which is higher than the process variable, so the electric fan will be stopped. Now what I'll do here is to hit this circuit, use this higher dryer.